He holds 2 PhDs, one in philosophy and one in theology. His research interests are quite broad, but for today, what we're going to be focusing on is research interests in the philosophy of time and theology. So what exactly is God's relationship to time? Over the years, he's published several volumes related to these issues. He has 2 different books, one on tensed theory of time and another on the tenseless theory of time, as well as 2 different volumes on God, time, and eternity, and a lay version called Time and Eternity, and as well as a book on time and the metaphysics of relativity. Craig holds a position that is not exactly traditional. He argues that God is temporal and not timeless, yet he's not straight up a temporalist. He holds that God is timeless sans creation, yet temporal with creation. Where relativity comes into play is that Craig holds to a tensed theory of time, and it seems that relativity might cause problems with this. Or relativity theory might entail that somehow God could be timeless if God doesn't in fact exist. So these are the issues that Greg will you're dealing with.
Right.
Okay, good. It'd be awkward if he wasn't. Thank
you. Thank you very much. Well, I too am very glad to be a participant in this conference and have enjoyed it so far. If Chris Hooley's paper represented the worst or the best of all possible worlds, because he had neither a presentation on PowerPoint nor a paper to be read, then my paper must represent the worst of all possible worlds because I've got both. God, declares the prophet Isaiah, is the high and lofty one who inhabits eternity. But being a prophet and not a philosophical theologian, Isaiah did not pause to reflect upon the nature of divine eternity. Minimally, to be eternal is to exist without beginning and end. To say that God is eternal means minimally that he never came into being and will never go out of being. To exist eternally is to exist permanently, where an entity is permanent if and only if it exists and has no first or last finite period of existence, and there are no moments before or after it exists. There are, however, at least 2 ways in which something could exist eternally. One way would be to exist omnitemporally, throughout infinite time. In this case, God would have an immemorial and everlasting temporal duration. The other way in which a being could exist eternally would be by existing timelessly. In this case, God would completely transcend time, having neither temporal location nor temporal extension. He would simply exist in an undifferentiated, timeless state. The question confronting the natural theologian in understanding God's eternity concerns God's relationship to time. Does God exist temporally or atemporally? God exists temporally if and only if he exists in time. That is to say, if and only if his duration has phases which are related to each other as earlier and later. In that case, as a personal being, God has experientially a past, a present, and a future. No matter what moment in time we pick, given God's permanence, the assertion, God exists now, were we to make it, would be literally true. By contrast, God exists atemporally, if and only if he is not temporal. This definition makes it evident that temporality and timelessness are contradictories. An entity must exist one way or the other and cannot exist both ways at once. If then God exists atemporally, he has no past, present, and future. At any moment in time, it would be true to assert God exists in the tenseless sense of exists, as when one says the natural numbers exist, but not true to assert God exists now. Philosophical theologians have been sharply divided on the question of God's relationship to time. One of the most important arguments motivating a doctrine of divine timelessness is based upon Albert Einstein's special theory of relativity, hereafter STR. In this paper, I want to focus our attention on this particular argument. According to Einstein's special theory, there is no unique universal time, and so no unique worldwide now. Each inertial frame has its own time and its own present moment. And there is no everlasting, or rather no overarching absolute time in which all these diverse times are integrated into one. So, if God is in time, then the obvious question raised by STR is, whose time is he in? The defender of divine timelessness maintains that there is no acceptable answer to this question. We cannot plausibly pick out some inertial frame and identify its time as God's time, because God is not a physical object in uniform motion, and so the choice of any such frame would be wholly arbitrary. Moreover, it's difficult to see how God, confined to the time of one inertial frame, could be causally sustaining events which are real relative to other inertial frames, but are future or past relative to God's frame. Similarly, God's knowledge of what is happening now would be restricted to the temporal perspective of his frame, leaving him ignorant of what is going on in other frames. In any case, were God to be associated with a particular inertial frame, then surely as God's time, the time of that frame would be privileged. It would be the equivalent of the privileged ether frame of classical physics. So long as we maintain with Einstein that no frame is privileged, then we cannot plausibly identify the time of any inertial frame as God's time. Neither can we say that God exists in the now associated with the time of every inertial frame. For this would obliterate the unity of God's consciousness. In order to preserve God's personal consciousness, it must not be fragmented and scattered among the inertial frames in the universe. But if God's time cannot be identified with the time of a single frame or of a plurality of frames, then God must not be in time at all. That is to say, he exists timelessly. We can summarize this reasoning as follows. 1. STR is correct in its characterization of time. 2. If STR is correct in its characterization of time, then if God is temporal, he exists in either the time associated with a single inertial frame or the times associated with a plurality of inertial frames. 3. Therefore, if God is temporal, he exists in either the time associated with a single inertial frame or the times associated with a plurality of inertial frames. 4. God does not exist in either the time associated with a single inertial frame or the times associated with a plurality of inertial frames. 5. Therefore, God is not temporal. How shall we assess this argument? Well, let's look at premise 2 first. Premise 2 is at best misleading in that it fails to take into account the fact that STR is a restricted theory of relativity and therefore is correct only within prescribed limits. It is a theory which deals with uniform motion only. The analysis of non-uniform motion, such as acceleration and rotation, is provided by the general theory of relativity, hereafter GTR. STR cannot therefore be expected to give us the final word about the nature of time and space. Indeed, within the context of GTR, a new and important conception of time emerges. For GTR serves to introduce into relativity theory a cosmic perspective, enabling us to draft cosmological models of the universe governed by the gravitational field equations of GTR. Within the context of such cosmological models, the issue of time resurfaces dramatically. All contemporary cosmological models derive from Russian mathematician Alexander Friedmann's 1922 model of an expanding material universe characterized by ideal homogeneity and isotropy. Although GTR does not itself mandate any formula for how to slice space-time into a temporally ordered foliation, nevertheless, certain models of space-time, like the Friedmann model, have a dynamical, evolving spatial geometry whose natural symmetries guide the construction of a cosmic time. In order to ensure a smooth development of this geometry, it will be necessary to construct a time parameter based on a preferred slicing of space-time. Now, as a parameter independent of spatial coordinates, cosmic time measures the duration of the universe as a whole in an observer-independent way. That is to say, the lapse of cosmic time is the same for all observers. Nevertheless, cosmic time is related to the local times of a special group of observers called fundamental observers. These are hypothetical observers who are at rest with respect to the expansion of space itself. Cosmic time relates to these observers in that their local times all coincide with cosmic time in their vicinity. Because of their mutual recession, the class of fundamental observers do not serve to define a global inertial frame, technically speaking, even though all of them are at rest. But since each fundamental observer is at rest with respect to space, the events which he calculates to be simultaneous will coincide locally with the events which are simultaneous in cosmic time. What this implies is that, contrary to premise 2, it does not follow from the correctness of STR that if God is in time, then he is in the time of one or more inertial frames. For if God exists in cosmic time, there is no universal inertial frame with which he can be associated. But let that pass. Although it may come as something of a shock to many, it seems to me that the most dubious premise in the foregoing argument is premise 1. In order to understand why I say this, it will be helpful to take a backward glance at Isaac Newton's classical doctrine of absolute time and space, which was superseded by STR. The locus classicus of Newton's exposition of his concepts of time and space is the scholium to his definitions in the Principia Mathematica. In order to overcome what he called common prejudices concerning such quantities as time, space, place, and motion, Newton draws a dichotomy with respect to these quantities between absolute and relative, true and apparent, mathematical and common. With respect to time, he asserts, and I quote, absolute, true, and mathematical time of itself and from its own nature flows equably without relation to anything external, and by another name is called duration. Relative, apparent, and common time is some sensible and external, whether accurate or unequal, measure of duration by the means of motion, which is commonly used instead of the true time, such as an hour, a day, a month, a year. The most evident feature of this distinction is the independence of absolute time from the relative measures thereof. Absolute time, or simple duration, exists regardless of the sensible and external measurements which we try, more or less successfully, to make of it. Excuse me. Newtonian time is thus, first of all, absolute in the sense that time itself is distinct from our measures of time. But Newton also conceived of time as absolute in yet a more profound sense. Namely, he held that time exists independently of any physical objects whatsoever. Usually, this is interpreted to mean that time would exist even if nothing else existed, that we can conceive of a logically possible world which is completely empty except for the container of absolute space and the flow of absolute time. But here we must be very careful. Modern secular scholars tend frequently to forget how ardent a theist Newton was, and how central this theism played in his metaphysical outlook. In fact, Newton makes quite clear in the general scholium to the Principia, which he added in 1713, that absolute time and space are constituted by the divine attributes of eternity and omnipresence. He writes, God is eternal and infinite. That is, his duration reaches from eternity to eternity. His presence from infinity to infinity. He is not eternity and infinity, but eternal and infinite. He is not duration or space, but he endures and is present. He endures forever and is everywhere present. And by existing always and everywhere, he constitutes duration and space. Since every particle of space is always, and every indivisible moment of duration is everywhere, certainly the maker and Lord of all things cannot be never and nowhere. Because God exists, there exists an everlasting duration. And because he is omnipresent, there exists an infinite space. Absolute time and space are therefore relational in that they are contingent upon the existence of God. In Newton's view, God's now is thus the present moment of absolute time. Since God is not, quote-unquote, a dwarf God located at a particular place in space, but is omnipresent, there is a worldwide moment which is absolutely present. Newton's temporal theism thus provides the foundation for absolute simultaneity. The absolute present and absolute simultaneity are features first and foremost of God's time, absolute time, and derivatively of measured or relative time. Thus, the classical Newtonian concept of time is firmly rooted in a theistic worldview. What Newton did not realize, nor could he have suspected, is that physical time is not only relative, but also relativistic, that the approximation of physical time to absolute time depends not merely upon the regularity of one's clock, but also upon its motion. Unless a clock were at absolute rest, it would not accurately register the passage of absolute time. Moving clocks run slowly. This truth, unknown to Newton, was finally grasped by physicists only with the advent of relativity theory. Where Newton fell short then was not in his analysis of absolute or metaphysical time. He had theological grounds for positing such a time, but in his incomplete understanding of relative or physical time. He assumed too readily that an ideal clock would give an accurate measure of time independently of its motion. If confronted with relativistic evidence, Newton would no doubt have welcomed this correction and seen therein no threat at all to his doctrine of absolute time. In short, relativity corrects Newton's concept of physical time, not his concept of absolute time. What Einstein did, in effect, was simply to remove God from the picture and to substitute in his place a finite observer. According to historian of science Gerald Holton, thus the relativity theory merely shifted the focus of space-time from the sensorium of Newton's God to the sensorium of Einstein's abstract Gedanken experimenta, as it were, the final secularization of physics. By rejecting Newton's absolute time and space, and along with them, the ether, relativity theory left behind only their empirical measures. Since these are relativized to inertial frames, one ends up with the relativity of simultaneity and of length. What justification did Einstein have for so radical a move? How did he know that absolute time and space do not exist? The answer, in a word, is verificationism. Historians of science have demonstrated convincingly that at the philosophical roots of Einstein's theory lies a verificationist epistemology mediated to the young Einstein through the influence of Ernst Mach, which comes to expression in Einstein's analysis of the concepts of time and space. In 1905, when Einstein published his paper on the electrodynamics of moving bodies, and for several years thereafter, he was a self-confessed epistemological pupil of Mach, and the epistemological analysis of space and time, given in the opening sections of this paper, clearly displays this influence. Mach's positivism manifests itself most clearly in Einstein's a priori rejection of absolute time and space and reliance on operational definitions of crucial concepts. Absolute time, or a privileged frame, is presumed not to exist because, quote, to the concept of absolute rest, there correspond no properties of the phenomena, end quote. It is taken for granted that, quote, all our judgments in which time plays a role must have a physical meaning. When it comes to judgments concerning the simultaneity of distant events, the concern is to find a practical arrangement to compare clock times. In order to define a common time for spatially separated clocks, we assume that the time light takes to travel from A to B is equal to the time it takes to travel from B to a definition which presupposes that absolute space does not exist. Thus, time is reduced to physical time, clock readings, and space to physical space, readings of measuring rods. And both of these are relativized to local frames. Simultaneity is defined in terms of clock synchronization via light signals. All of this is done by mere stipulation. Through Einstein's operational definitions of time and space, Mach's positivism triumphs in the special theory of relativity. Reality is reduced to what our measurements read. Newton's metaphysical time and space, which transcend operational definitions, are implied to be mere figments of our imagination. In Einstein's other early papers on relativity, his verificationist theory of meaning comes even more explicitly to the fore. Concepts which cannot be given empirical content and assertions which cannot be empirically verified in principle are discarded as meaningless. In his article in the Jahrbuch der Radioaktivität und Elektronik of 1907, after giving his operational definitions for time and simultaneity, he asserts that to refer to the time of an event without reference to its inertial frame has no sense, Sinn. In his piece in the Physikalische Zeitschrift of 1909, he asserts that statements about the time of an event have no meaning, Bedeutung, unless one refers to clocks at rest in the relevant inertial system. In his summary paper, the Relativitätstheorie, published in 1911, Einstein expresses himself at greater length concerning the meaning of statements about time and space. He says, and I think I have a quotation of this, no. He says, in order to arrive at time specifications of a very precise sense, we use a prescription that relates to clocks, which are relative to a certain coordinate system K. We have not gained simply a time, he says, but a time relative to a coordinate system. Quote, it is not said that time has an absolute meaning. That is an arbitrary element which was contained in our kinematics. We then come, Einstein proceeds, to the second arbitrary element in kinematics, the absolute length of a body. Quote, we now ask, how long is this rod? This question can only have the meaning, what experiments must we carry out in order to discern how long the rod is, end quote. Einstein then proceeds to describe length measurements of a moving rod by means of synchronized clocks. By abandoning the presuppositions of absolute time and space and substituting in their stead operational definitions, Einstein reduces time and space to our measurements of them. He concludes, quote, since we have in a precise way physically defined coordinates and time, every relation between spatial and temporal entities will have a very precise physical content, end quote. Statements about spatial or temporal relations which are metaphysical in character, that is, are independent of clocks, rods, and reference frames, are nonsense. It is frequently asserted that as Einstein labored on the general theory, he came to see the bankruptcy of Mach's positivism. But this claim needs to be carefully qualified. What Einstein's work on GTR, in fact, revealed to him was the inadequacy of Mach's phenomenalism. Scientific theorizing is not the mere linking of observation statements, but involves a creative exercise of the mind, which is free to postulate theoretical entities not directly given in observation. Nevertheless, even after GTR, he continued to regard such theoretical terms as meaningless unless they could somehow be linked to observation statements. In 1920, for example, he writes, we thus require a definition of simultaneity such that this definition supplies us with the means by which, in the present case, he can decide by experiment whether the lightning strokes occurred simultaneously. As long as this requirement is not satisfied, I allow myself to be deceived as a physicist. And of course, the same applies if I am not a physicist, when I imagine that I am able to attach a meaning to the statement of simultaneity. For physicists and non-physicists alike, the statement that two events occur simultaneously is meaningless unless an operational definition can be given for that concept. Thus, he continued to cling to his rejection of metaphysical space and time. He says, the only justification for our concepts and system of concepts is that they serve to represent the complex of our experiences. Beyond this, they have no legitimacy. I am convinced that the philosophers have had a harmful effect upon the progress of scientific thinking in removing certain fundamental concepts from the domain of empiricism, where they are under our control, to the intangible heights of the a priori. For even if it should appear that the universe of ideas cannot be deduced from experience by logical means, but is, in a sense, a creation of the human mind, without which no science is possible, nevertheless, this universe of ideas is just as little independent of the nature of our experiences as clothes are of the form of the human body. This is particularly true of our concepts of time and space, which physicists have been obliged by the facts to bring down from the Olympus of the a priori, to adjust them and put them in a serviceable condition. Einstein's theory, far from disproving the existence of absolute space, actually presupposes its non-existence. All of this is done by mere stipulation. Reality is reduced to what our measurements read. Newton's metaphysical time and space, which transcend operational definitions, are implied to be mere figments of our imagination. How then shall we assess the claim that STR has eliminated absolute time and space? Well, the first thing that needs to be said is that the verificationism which characterized Einstein's original formulation of STR belongs essentially to the philosophical foundations of the theory. The whole theory rests upon Einstein's redefinition of simultaneity in terms of clock synchronization via light signals. But that redefinition assumes necessarily that the time which light takes to travel between two relatively stationary observers, A and B, is the same from A to B as from B to A in a round-trip journey. That assumption presupposes that A and B are not both in absolute motion, though relatively stationary with respect to each other. Or in other words, that absolute space nor a privileged reference frame exists. The only justification for that assumption is that it is empirically impossible to distinguish uniform motion from rest relative to such a frame. And if absolute space and absolute motion or rest are undetectable empirically, therefore they do not exist, and may even be said to be meaningless. But if verificationism belongs essentially to the foundations of STR, the next thing to be said is that verificationism has proved to be completely untenable and is now obsolete. The untenability of verificationism is so universally acknowledged that it will not be necessary to rehearse the objections against it here. Verificationism provides no justification for thinking that Newton erred, for example, in holding that God exists in a time which exists independently of our physical measures of it and which may or may not be accurately registered by them. It matters not a whit whether we finite creatures know what time it is in God's absolute time. God knows, and that is enough. Now, I am not here endorsing Newton's view on divine eternity, but I am saying that the natural theologian who, like Newton, believes God to be temporal need not be fazed by STR, because STR's claim that absolute time does not exist is founded essentially upon a defunct and untenable epistemology. If we do suppose that God is in time, then how should we understand STR? Henri Poincaré, the great French mathematician and precursor of STR, helped to point the way. In a fascinating passage in his essay, The Measure of Time, Poincaré briefly entertains the hypothesis of an infinite intelligence, une intelligence infinie, and considers the implications of such a hypothesis. Poincaré is reflecting upon the problem of how we can apply one and the same measure of time to spatially distant events. What does it mean, for example, to say that two thoughts in two people's minds occur simultaneously? Or what does it mean to say that a supernova occurred before Columbus saw the New World? Like a good verificationist, Poincaré says, and I quote, "All these affirmations have by themselves no meaning." Then he remarks, we should first ask ourselves how one could have had the idea of putting into the same frame so many worlds impenetrable to one another. We should like to represent to ourselves the external universe, and only by so doing could we feel that we understood it. We know that we can never attain this representation. Our weakness is too great. But at least we desire the ability to conceive an infinite intelligence for which this representation could be possible, a sort of great consciousness which should see all and which should classify all in its time as we classify in our time the little we see. This hypothesis is indeed crude and incomplete, because this supreme intelligence would be only a demigod. Infinite in one sense, it would be limited in another, since it would have only an imperfect recollection of the past. It could have no other, since otherwise all recollections would be equally present to it, and for it there would be no time. And yet, when we speak of time, for all which happens outside of us, do we not unconsciously adopt this hypothesis? Do we not put ourselves in the place of this imperfect God? And do not even the atheists put themselves in the place where God would be if he existed? What I have just said shows us perhaps why we have tried to put all physical phenomena into the same frame. But that cannot pass for a definition of simultaneity, since this hypothetical intelligence, even if it existed, would be for us impenetrable. It is therefore necessary to seek something else. Poincaré here suggests that in considering the notion of simultaneity, we instinctively put ourselves in the place of God and classify events as past, present, or future according to his time. Poincaré does not deny that from God's perspective, there would exist relations of absolute simultaneity. But he rejects the hypothesis as yielding a definition of simultaneity because we could not know such relations. Such knowledge would remain the exclusive possession of God himself. Clearly, Poincaré's misgivings are relevant to a definition of simultaneity only if one is presupposing some sort of verificationist theory of meaning, as he undoubtedly was. The fact remains that God knows the absolute simultaneity of events, even if we grope in total darkness. Nor need we be concerned with Poincaré's worry that such an infinite intelligence would be a mere demigod, since there is no reason to think that a temporal being cannot have a perfect recollection of the past. There is no conceptual difficulty in the idea of a being which knows all past tense truths. His knowledge would be constantly changing as more and more events become past, but at each successive moment, he could know every past tense truth that there is at that moment. Hence, it does not follow that if God is temporal, he cannot have perfect recollection of the past. Poincaré's hypothesis suggests, therefore, that if God is temporal, his present is constitutive of relations of absolute simultaneity. Compare H.A. Lorentz's illustration of a world spirit, or Weltgeist, in his letter to Einstein in January of 1915. In words redolent of the general scholium and optics of Newton, Lorentz broached considerations whereby, he said, I cross the borderland of physics. He wrote, a world spirit who, not being bound to a specific place, permeated the entire system under consideration, or in whom this system existed, and who could feel immediately all events, would naturally distinguish at once one of the systems, U prime, etc., above all the others. Such a being, says Lorentz, could directly verify simultaneity. On this view, the philosopher J.N. Findlay was wrong when he said, the influence which harmonizes and connects all the world lines is not God, not any featureless, inert medium, but that living, active interchange called light, offspring of heaven, firstborn. On the contrary, the use of light signals to establish clock synchrony would be a convention which finite and ignorant creatures have been obliged to adopt. But the living and active God, who knows all, would not be so dependent. In God's temporal experience, there would be a moment which would be present in absolute time, whether or not it were registered by any clock time. He would know without any dependence on clock synchronization procedures or any physical operations at all, which events were simultaneously present in absolute time. He would know this simply in virtue of his knowing at every such moment the unique class of present tense truths at that moment without any need of physical observation of the universe. So, what would become of STR if God is in time? From what has been said, God's existence in time would imply that H.A. Lorentz, rather than Einstein, had the correct physical interpretation of the mathematical core of relativity theory. That is to say, Einstein's clock synchronization procedure would be valid only in the preferred or absolute reference frame, and measuring rods would contract and clocks slow down in the customary special relativistic way when in motion relative to the preferred frame. Such an interpretation would be implied by divine temporality, for God, in the now of absolute time, would know which events in the universe are now being created by him and are therefore absolutely simultaneous with each other and with his now. This startling conclusion shows that Newton's theistic hypothesis is not some idle speculation, but has important implications for our understanding of how the world is and for the assessment of rival scientific theories. Lorentzian relativity is admitted on all sides to be at least empirically equivalent to Einsteinian relativity. And there are even indications on the cutting edge of physics today that a Lorentzian view may be preferable in light of recent discoveries. In fact, due to developments in quantum physics, there has been what one participant in the debate has called a sea change in the attitude of the physics community toward Lorentzian relativity. Again, none of this proves that Newton was right in thinking that God is in time, but it does undercut the claim that STR has proven Newton to be wrong. The defender of divine temporality can plausibly reject the first premise of the argument for divine timelessness based on the special theory of relativity. In conclusion, relativity theory does not provide good grounds for thinking that God is timeless. The Einsteinian interpretation of STR is based essentially upon an untenable and obsolete verificationist epistemology, and so cannot force abandonment of the classical concept of absolute time, which is constituted by God's duration. Moreover, GTR, in its cosmological application, furnishes us with a cosmic time parameter which may be plausibly interpreted as the appropriate measure of God's time since the moment of creation. Thank you.
Two things before we start the Q&A. First, please try to keep your questions short and sweet. Second, do not eat the microphone when it comes around to you. So try to keep it like kind of this distance away instead of eating it, so that will prevent you from popping your peas and whatnot. Okay. All right. First question. One of these people over here, just you, and then the one next to you. We'll do it in order.
Thank you very much for that. I was wondering, however, your insistence on the role of verification, whether that's really essential to the picture that you want to bring out. But,
yes.
I mean, we don't no longer believe in verification, so we know that what's empirically meaningless is not necessarily meaningless. Period. But it's still the case that unless you want to put God in the natural world, if absolute space and time are empirically meaningless within spatial relativity, and if we take assume spatial relativity as a model of the natural world, then absolute space and time don't play any role in the natural world. So one can still take spatial relativity at face value as showing that within the natural world there is no space for absolute place and time, while saying that it's totally meaningful to talk about absolute space and time and give them a theological significance.
Yes.
You may want to talk about what God does in the natural world, but that's another story.
Yes. I think it's clearly meaningful to talk about notions of absolute simultaneity and absolute length, even if these are not empirically verifiable. But I would disagree when you said that therefore they play no role in physical theory. Because if they do exist, then there is structure to space-time or to space that doesn't exist according to the Einsteinian interpretation of STR. The Lorentzian interpretation, physical interpretation of the Lorentz transformation equations, which are at the heart of the theory, is a different interpretation than both the Einsteinian interpretation in the 1905 paper as well as Minkowski's 1908 reformulation of it in terms of the four-dimensional geometry. These differences between the physical interpretations of the theory were glossed over by the positivists, because so long as they were empirically equivalent, they could be regarded as the same theory. But with the collapse of verificationism and positivism, what we have here are different ontological structures. And so it isn't a matter of indifference. It does make an ontological difference, whether or not we're talking about Lorentzian relativity versus Einsteinian or Minkowskian relativity. Now, whether or not this is detectable, as I say, that is right now a very controverted question on the cutting edge of physics, to which earlier speakers have already alluded in the violation of the Bell inequalities by space experiments and what implications this might have for establishing absolute simultaneity. But we can leave that all aside. I think the more fundamental point is that once you get rid of verificationism, these are not the same theories. These are different ontologies.
In that same vein, I want to take a little bit on your interpretation of what Einstein is up to here. I think, and I wish that Ryan Pitts were here to give this talk, because I think he would have been speaking about Einstein's difference between theories of explanation and theories of construction. And I think that's what he's doing in these statements. He's not giving an ontological interpretation in terms of verification of what's going on in space and time in STR. He's talking about the way he was able to proceed in his theorizing in the electrodynamics of moving bodies. So by saying, look, Lorentz and Poincaré are not getting anywhere by thinking about what the smallest bits of the theory are and trying to construct something out of that. Instead, I'm going to approach the whole problem by thinking about, well, what have we actually measured? What principles do we already have? We've got the speed of light. We know that's limitation. We also know that frames are invariant. That the laws of physics are frame invariant. And so starting from those two things, we can drive all this other stuff. So when he's explaining STR, he's not saying something ontological about space and time based on the fact that he started in his paper from principles of what we actually measure. He's not saying because we have these things empirically, that's it, there's no meaning to anything else. It was just the way he approached the problem. Is that?
I think you're quite right in distinguishing between theories of explanation and theories of principle, and that this is a theory of principle, as you say. The special theory, as Einstein developed it, is explanatorily vacuous. The three-dimensional objects that undergo these deformations as they are in uniform motion relative to each other are real physical deformations. These rods actually contract up. The clocks actually slow down. This isn't mere appearance. And there's no explanation for this at all. As you say, in the original paper, they are simply deductions from the two postulates. But what's critical to see, and here is where I think that you're overlooking something, is that those two postulates are not themselves empirically established. The postulate of the sameness of all physical laws in every reference frame is based upon the assumption that absolute space does not exist. Otherwise, the two postulates of the theories are in contradiction to each other. The two postulates cannot both be true unless you presuppose that absolute space does not exist. So that's why I said the theory doesn't really disprove absolute space and time. It actually presupposes it. And those twin postulates you cannot be established empirically. They are, as you say, just postulates, just principles that one accepts, based upon the assumption that absolute space doesn't exist. And that assumption is rooted in this epistemology of verificationism that says if you can't detect it, it's not real. And Lorentz, in his correspondence with Einstein, came back to this over and over again. He would say, just because you can't detect something empirically doesn't mean it's not real. And so the great predecessors of STR, like Poincaré and Lorentz, were never convinced that Einstein's interpretation was right because they didn't accept the postulates.
Yes. So thanks very much. This is just a question of a request for clarification on terminology, I guess, really. So it is, as I'm sure you're familiar, the words absolute, when it's reference to space or time, can be used to mean a number of different things. And one of the things that absolute often gets confused with is the idea that there's a preferred frame of reference.
That's what?
That there's a preferred frame of reference. So, I mean, as you said a minute ago, the real difference between these interpretations is an issue of what we take to have to be a part of the structural foundations of the world, the structural foundations of space-time. It's a structural issue. I mean, the idea that there's a preferred frame of reference is the idea that space-time has more structure or less symmetry than it may under another interpretation. So how much does any of this really hinge upon whether or not space or time or space-time exist as entities? And how much is it an issue of what kind of structure those things have? So I mean, really, I guess I could just say the question is, can I be a relationalist, not believe in substantial space-time, and still take your side on this just because?
Absolutely.
Okay.
Yes, I think so. And in my book on this, I list and explain 6 different meanings of the word absolute that are in the literature. Absolute relational, absolute versus frame dependent. The word is used about 6 different ways. I mentioned 2 of them in the paper today. And any of these theories can be given a space-time formulation in terms of this 4-dimensional geometry. But if you hold to a tensed view of time, according to which temporal becoming is real, then I think you should reject the Minkowskian 4-dimensionalist space-time realist view, according to which the future is just as real as the present is as real as the past. And if you do that, then if Minkowski is out, what you're left with is either Lorentz or the original Einsteinian interpretation in the 1905 paper. And as I said, that 1905 paper is explanatorily vacuous. It posits these mysterious deformations of 3-dimensional objects without any sort of explanation at all for why it occurs. And the Minkowskian also sees this as a deficit of the relativity interpretation and instead wants to postulate a 4-dimensional geometry. But if you hold to the objectivity of temporal becoming and tense time, then you're going to throw out that space-time realism and I think have a tensed theory that is more plausibly Lorentzian than Einsteinian.
Sure, and if I can just to clarify then, but it is an issue of what kind of structural properties the material world has. I mean, you could even say that time, space-time, whatever, does not actually exist, but your perspective would then translate to a claim about what kind of structural properties the material world has.
My only hesitation is when you say material world. Because you see, I'm, as a theist, like Newton, I want to root this absolute simultaneity and absolute now, the present, in God's time, which isn't material. I would see the material realm as being derivative from God's metaphysical time. In fact, when you think about it, it seems to me that the universe is a clock. The universe is God's clock. It measures the duration of God's absolute time from the moment of creation forward in cosmic time. So I hesitate with respect to saying of the material world, but yes to what you said about postulating the structure of a sort of hypersurface of simultaneity on which present events exist and with respect to which temporal becoming is an objective feature of reality.
So if I understood correctly, all this problem started with the probably absence of frame, of a special time frame in Einstein's theory. But Einstein do have an absolute frame, which is the speed of light. So given that the Bible identifies a lot God with light, doesn't it appears to me that God does not live in time, but furnish time with reality and act also as a reference for time measurements?
Well, now, the speed of light being the same in all reference frames doesn't serve to define a unique frame in the special theory. But with respect to God, I haven't given any arguments here for thinking that God is temporal, but I do that in my other work. And would argue that given a tensed view of time, that God's omniscience, knowing the truth of all tensed truths, and his causal connection to a world of temporal becoming necessitates that God is in time. So I give independent arguments for thinking that if God exists, he's temporal, in view of his omniscience and causal connection to the world. And critical here will be your theory of time. I'm presupposing, well, and arguing for a tensed theory of time.
Paul. So you stated, if I understood correctly, that there is this absolute reference frame, and it's when I'm moving at a velocity with respect to this absolute reference frame that the meter stick changes size and the clock slows down.
Yes.
Wouldn't that give an empirical way to find the absolute reference frame, because we just look for the one with the longest meter stick and the shortest second?
No, because for observers in motion relative to the absolute frame, there isn't any way to empirically detect that you're not the one at rest and that the other frame is the one that's moving. So unless these recent experiments with respect to Bell's theorem and the violation of the Bell inequalities suggest that these two photons have relations of absolute simultaneity between them, either when the quantum collapse occurs or they're correlated in some way. That would be the best way of establishing relations of absolute simultaneity. And so people like J.S. Bell, for example, advocated going back to Lorentz in order to best explain the violation of the Bell inequalities. Otherwise, what you get are causal influences going backwards in time relative to some frame. But if you have relations of absolute simultaneity, then you won't have that. So that would be, I think, the best bet empirically of establishing this preferred frame.
Yes, well, thank you for your talk. There's something I came across recently in a book by Lee Smolin called The Trouble with Physics. I don't know if you've come across this at all. He points out something which many physics graduates, I mentioned for many years, is that there is at least one absolute distance length in physics, which is the Planck length, which doesn't scale up or scale down. So it's an interesting thing, it's a little fact that often gets missed when people talk about being able to transform any length into any other length depending on the reference frame, but the Planck length doesn't. So there's an interesting, I know there's some variations of special relativity, like double special, there's something called doubly special relativity, and some extensions of relativity, but they do involve absolute distance lengths.
I'm not familiar with that, nor have I read Smolin's book, so I can't comment. Thank you.
Yes.
You mentioned, or you said that in the in absolute time, the universe is or is like God's clock. How does that work?
Well,
how could there be a single clock
yes.
in the universe that we know?
As the universe expands, there is a kind of natural geometry in which the universe is homogeneous and isotropic. And you can then establish a cosmic time parameter that will measure the proper time of the duration of the universe back to its beginning. And it's important to understand this is not a coordinate time. Time is a parameter here that is independent of spatial coordinates. So it's not part of the space-time coordinates of events. This is a parameter which is independent of spatial coordinates and gives you how long the universe has existed. So when people say the universe is 13.7 billion years old, they're not talking about Earth time, they're talking about cosmic time. And this is the same for every observer in the universe, regardless of his state of motion. The universe in cosmic time is about 13.7 billion years old. And my suggestion is that that would be the natural measure of how long it's been since God created the world. So what could be clearer than that? That for God, it was 13.7 billion years ago that he created the world, and the universe is, in effect, a clock, measuring how long it's been.
Where do you get that unit of years?
Where do I get what?
We use the unit of the year.
Oh, I see.
So where do we get these units?
Well, those would be arbitrary. Obviously, that's a convention, but I mean, we get it from the Earth's orbital motion around the sun. But the interesting thing is that the Earth is very nearly at rest with respect to the microwave background radiation, which seems to coincide with this cosmic time. So we actually have a pretty good idea of what time it is in cosmic time. The Earth is slowly moving in the direction of the constellation Leo at about, I think, 360 kilometers per second or something like that. So that we have actually a pretty good measure of cosmic time using our clocks here on this planet. It's quite remarkable.
This actually speaks to this very last question. So on your view with Einstein, there is a preferred frame which God is sensitive to, but we're unable to identify. So is that not itself somewhat surprising? Why should this be hidden from us in this way?
Now, you know, I don't see any reason to think that if there is this sort of preferred frame, that it would need to disclose itself to us. In fact, these deformations are necessary in order to maintain the equilibrium of systems in motion so that they aren't destroyed. So that the hiddenness of the preferred frame, in a sense, could be an indication of the providential care of God. It's due to these sorts of deformations that physical objects are able to maintain their internal equilibrium. But in cosmic time, there I do think that this preferred time is revealed because of the expansion of the universe. We are able to detect what time it really is. And it's remarkable how the old classical ether has come back into modern physics under new guises. For example, I already mentioned the microwave background radiation, which is the microwave equivalent of the luminous ether of the 19th century, and we can actually detect the ether wind of our motion through the microwave background radiation. The quantum mechanical vacuum also is like a modern ether that coincides with this, and the preferred frame of expanding space. So there are quite a number of these sort of ether frame equivalent notions in modern physics that do give us rather a good idea of what time it really is. So I don't think nature is conspiring to conceal this from us.
What happens to God in time when particle encounters a black hole and approaches the singularity?
Right. The deviations from cosmic time that occur are due to either local gravitational effects or the type of motion that comes into view in the special theory of relativity. So cosmic time would define a kind of worldwide parameter that would measure the proper time of the universe. But locally, as in black holes, this will become distorted because of gravitational effects. Wheeler, Thorne, and Misner in their book on gravitation describe cosmic time as many-fingered. When you get into these black hole areas, it's like fingers, so to speak, in cosmic time, so that at the terminus of a black hole, it's the end of the universe there. It's the end of time. So I'm talking about these broad hypersurfaces globally that represent cosmic time, but you're quite right in saying in black holes and other local phenomena, you wouldn't have cosmic time registering this sort of global parameter. The deviations from cosmic time will be due to just local phenomena. So relativity is reduced to a local phenomenon, not a global one.
Okay, next to you. Did you have a question? No? Okay, take it away. You? Okay, then we're going to have time for one more after that.
I'd like to press you on this idea that the universe could be God's clock.
Yes.
Now, of course, if you go back towards the time when the microwave background radiation was created, then you actually you can measure the passage of years. And our civilization today measures the passage of time by the oscillations of cesium atoms. What do you do when the universe is the size of a cesium atom? I mean, ultimately, all your clocks are going down with you into the singularity.
Right.
So how do you resolve this?
Well, ultimately, this will break down, as you say, when you get back before the Planck time. Then you're not going to have any sort of physical mechanism that is going to operate. But I don't think that means time itself ceases to exist. It just means that you won't have a clock at that point. I think you're quite right about that.
Did you have a quick follow-up?
It's not a follow-up.
Oh, is it quick though? Or?
I can ask you quickly.
Okay, good.
So I have a good feel now for your reasons for preferring the neo-Lorentzian approach to space-time than Einstein as it was in 1905. If you were to compare, say, the approach to space-time that we get from Minkowski in 1908, 1909, I don't yet have a really good understanding as to why you prefer the neo-Lorentzian approach, other than the fact that it's more compatible with the view that you presented on God's relation to time. Do you have any other reasons for preferring the
Well, my main reason is because I'm just so deeply committed to a so-called A theory of time, a tense theory of time. In fact, I think that what really carries the water in this argument isn't so much God as the tense theory of time. Because if temporal becoming is an objective feature of the universe that is mind-independent, then it is simply not true that all events in space-time are equally real or on an ontological par. And there are all sorts of other deleterious consequences to space-time realism. I think it implies, for example, perdurantism with respect to personal identity over time. I'm literally not the same person that walked into this room this morning. I'm a later temporal stage of a four-dimensional worm, but not the same as the earlier stage. And this has all kinds of crazy consequences for personal identity, moral responsibility, and so forth. So in my book, again, I lay out my best case against the tenseless theory of time, and hence this Minkowskian space-time realism which presupposes it, as well as thinking that there's no good reason to adopt such a breathtaking metaphysic of the world as to think that our experience of temporal becoming is an illusion, and that all events, whether past, present, future, are equally real. It seems to me that's a gratuitous reification of a diagram in which space and time are plotted together on a piece of paper, but there's no reason to invest that diagram with actual reality.
Sorry, we're out of time now. So we've got coffee. Like I said, hopefully James Layton will be here soon, and we'll finish this.